The environment around Sagittarius A star is very dynamic. It can actually be a really hellish place. There's this accretion disk that's full of plasma, it's heated to thousands of degrees. So you wouldn't necessarily think that that's a great place for star formation to happen.
But that's exactly where astronomers decided to look. Using the Atacama Large Millimeter Array, or ALMA for short, scientists scanned the heart of the Milky Way for dense cores of gas and dust, stellar embryos. They found more than 800 within just 1,000 light years of Sagittarius A star, including more than 40 embryos with energetic jets blasting from their cores, the telltale sign of the birth of stars.
It's really surprising to find those stars there. It's like hearing babies' cries from a wolf's den.
It's not the place you would expect this to happen, but in fact, stars are forming there. Now, it's not as efficient as it is out here in the suburbs where things are quieter, but it works.
Baby stars igniting and thriving around a supermassive black hole, the kind of hostile environment we know existed in the young cosmic web. Star birth is a key part of kickstarting young galaxies. This evidence suggests that star formation is more resilient than researchers thought. And they've developed a theory to explain it. Gas and dust race around the black hole in the accretion disk. Heated to incredible temperatures, plumes of gas break off and blast into space. The gas rapidly cools, collapses, and forms baby stars. These accretion disks are the most chaotic of stellar nurseries.
You see this mechanism that you think is violently inhibiting star formation, and at the same time it's triggering the birth of new stars.
Matter clumps at the cosmic web's intersections, feeding the supermassive black holes. Around them, stars burst into life, slowly building galaxies. This could be how our own Milky Way formed among the filaments of the young cosmic web. But new research suggests that growth in these baby galaxies requires murder and mayhem, and without them, we wouldn't exist. The infant universe is a dramatic place. Stars ignite and stars die, even in the violent surroundings of supermassive black holes. Baby galaxies form with the cosmic web. But how do they grow? Scientists believe the critical factor is galactic turmoil.
The universe does need to churn things up. You need to break some eggs to make an omelet. You need to introduce some chaos into your galaxy to rapidly form stars or grow black holes.
Smashing things together is how the universe came to be.
The Hubble Space Telescope discovers many distorted galaxies, twisted, battered, and torn, victims of violent collisions on a cosmic scale.
Galaxies are never sitting quietly doing nothing. They're always undergoing change. They're constantly encountering and slamming into and colliding with and mixing with other galaxies.
You can see images in Hubble of total car wrecks of galaxies that are trying to merge with each other.
We know that galaxies collide now. But what about in the early universe, when the cosmic web was beginning to take shape? Astronomers study a strange galaxy named Himiko, born just 800 million years after the Big Bang. 3 bright light sources suggest intense star formation. Detailed analysis reveals not one galaxy, but 3 baby galaxies, not yet fully formed. Scientists call these youthful star systems protogalaxies. The trio that make up Himiko are in mid-collision. Computer simulations of the early universe suggest protogalaxies smash together with frightening regularity. These violent shakeups trigger star birth.
Protogalaxies are rich in gas, and when they collide and merge, those gas clouds collide and collapse and form stars, sometimes at prodigious rates. And after 1 billion years or so, all of that structure forms and you get a formal galaxy.
Picture the early universe, 500 million years after the Big Bang. It's smaller and more compact than today. Cosmic collisions are common.
Imagine taking a bunch of cars and just letting them drive around in Nevada where there's nothing but space, right? You're not going to get too many collisions. Now squeeze them into a tiny little city block someplace and you're just going to have accidents everywhere. Well, it's the same thing with the universe. When the universe was younger, it was smaller and these protogalaxies were everywhere. It was crowded. You were bound to get collisions between them back then.
More and more baby galaxies form at the growing web's gas-rich intersections. A collision between small protogalaxies might trigger modest amounts of star formation when regions of dense matter come together. But a merger involving protogalaxies with rich reserves of gas can rev up the rate of stellar ignition, supercharging a growing galaxy.
Gas-rich mergers can generate star-burst galaxies, where we see incredibly vigorous events of star formation.
You might think that any trace of the original galaxies would be destroyed in the crash, but scientists pick over the remains of these cosmic train wrecks. By analyzing the crash scene, they can piece together the collisions, blow by blow. They've even done it in our own galaxy.
We think that our very own home galaxy of the Milky Way almost certainly experienced several of these galactic collisions in its past. We can learn this by looking at stars in the Milky Way, and we can figure out that some of them are moving at different orbits, some of them are made of different elements, and that gives us the clue that our Milky Way has experienced this series of mergers over the course of its history.
Astronomers think one such smash-up around 10 billion years ago kick-started the growth of the Milky Way. A group of stars called the Gaia Enceladus cluster in the outer reaches of the galaxy behaves strangely compared to other stars around it.
The stars in the Gaia Enceladus cluster, they're different. They move differently. They act different. They're like kids from the next town over showing up at your school. You just know that they don't belong. The Milky Way had already largely formed, and then this massive cluster comes screaming in. It was a violent event that eventually ended up absorbing the stars from this cluster into the body of the Milky Way itself. Galaxies are built from these kinds of collisions.
Less than 1 billion years after the Big Bang, the dark scaffold of the cosmic web begins to glow. Matter channeled down the web's tendrils creates dense clumps of gas. Even in the turbulent neighborhoods of supermassive black holes, stars burst into life. Baby galaxies collide, and the young universe sparkles with light. But an important question remains. In the mayhem of the early universe, how did galaxies like our Milky Way survive and thrive?
Galaxy evolution is very dynamic. Our understanding of galaxy evolution is very dynamic, and there's so much that we still don't know. There's a lot of different competing theories right now as to how galaxies grew into the galaxies that we see today. It's a huge open question, and is something that's a big deal in science right now.
New research suggests that life and death in the cradle of the universe lay within the cosmic web. 13.6 billion years ago, a protogalaxy, the infant Milky Way, forms in the tendrils of the young cosmic web. Today, it bears the scars of many collisions. Each one could have torn it apart. So what controls if a young galaxy lives or dies? May, 2020. Scientists image a graceful galaxy that existed just 1.4 billion years after the Big Bang. Analysis of its light shows this is a starburst galaxy, pumping out newborn stars.
Galaxies like our Milky Way are old and rather stately, and they don't form stars very rapidly, about the equivalent of the mass of the sun every year. Well, starburst galaxies, yeah, they form them a lot more quickly, hundreds of solar masses per year. But BRI 13350417, 4,650 times the mass of the sun every year. It is blasting out stars.